So here is part 2 of the 1.3 note. We are now going to solve quadratic equations by factoring. So let's talk about the zero product property. This says if AB, so A times B equals 0, then A equals 0 or B equals 0. And so what this means is once you factor the quadratic, you're going to set each factor to 0 and solve. So when we are solving, these are what we call our solutions. So whenever you get your x equals or whatever variable equals, that's your solutions. Now there are some other names to these. The other names are roots, zeros, and x-intercepts. The reason being is that you are basically finding the x-intercepts when you're solving for quadratic equations, okay? So that's why we can also call them x-intercepts. So if I had my graph, I have my quadratic, here are my x-intercepts, and you're solving for them. Okay? So that's basically what we are doing whenever we do solve any quadratic equation. And later on, you'll see that we will be solving in different ways. Okay. So now it says, what must be true about a quadratic equation before you can solve it using the zero product property? Well, we have to make sure that it has to be set equal to 0. So whenever we are solving by factoring, we need to make sure that the quadratic equation is set equal to 0, then we can solve. Okay, let's go ahead and try a couple examples here. Okay, what are the roots of the equation? Okay, let's figure out what are some other names for roots. We have solution or solutions. We have x-intercepts. And we have zeros. So remember, we are solving for the x-intercepts, finding basically where the graph crosses the x-axis. Okay, first thing is we need to make sure that our quadratic is set equal to 0, and we can see that in this example. So now, what we can do is factor. So let's figure out all the numbers that multiply to 36. We got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Which pair will add up to our negative 5x? That will be 4 and 9. So I have x and x, 4 and 9. Now, in order to get to a negative 5, we need to make sure 9 is the negative and 4 is the positive. And don't forget, we need to set this equal to 0. Now, to solve, we're going to set our factors equal to 0. So the factors are x plus 4 and x minus 9. So I have x plus 4 equal to 0, and I have x minus 9. So I move the 4 over by subtracting, so I get x equals negative 4, and I add 9 to the other side, so I get x equals 9. So my two solutions, or in this case, roots, are going to be x equals 4 and x equals 9. So what does this mean if we were graphing? Well, first of all, if we look at x squared minus 5x minus 36, which way is this going to open, up or down? It's going to open up because notice that our a value is positive. Okay, so we have let's just say this is negative 4, and over here it's 9. So when we have this, basically saying that we have negative 4 zeros, we cross that negative 4 0, and we cross that 9 0. So our two x-intercepts here are negative 4 0 and 9 0, and that's where our graph crosses the x-axis. Okay, let's try another one of these. Okay, so here it says zeros. So x-intercepts or solutions of the equations. Okay. Value of x when y equals 0. So in example 5, we're going to find the zeros of the function. So to find the zeros, the very first thing we need to do is make sure our equation is set equal to 0. So we're going to do that for both A and B. So changing the y into 0. So we have 0 equals x squared minus x minus 12. And we're going to do that for B as well. So 0 equals x squared plus 12x plus 36. So what I would like you guys to go ahead and do is pause the video and solve for both A and B. Okay, let's see what you got here. So I have 0 equals. So list all the numbers that multiply to 12. We got 1 and 12, 2 and 6, and 3 and 4. Which pair will add up to that negative 1x? That's going to be 3 and 4. So I have x and x, 3 and 4. In order to add up to a negative, my 4 needs to be negative, and my 3 is going to be positive. Now I set each factor equal to 0 and solve. So I have x plus 3 and x minus 4. And remember, x plus 3 and the x minus 4, those are what we call factors. So I get x equals negative 3 and x equals 4. So those are my two solutions, two roots, two zeros, or two x-intercepts. So if we had to graph this, this means that we would cross the x-axis at negative 3, 0 and at 4, 0. Okay, let's try B here. So we're going to do the same thing. So we're going to factor. Let's list all the numbers that multiply to 36. Which pair will add up to that 12? It's going to be the 6 and 6. And notice it's positive. Now, do you notice, is this one of the special factors? Yes, this is a perfect trinomial, perfect square trinomial. So notice that our constant is a perfect square, 36. And when we have to have that 6 times 6, of course, when we add that up, it'll give us 12. So in this case, we're going to have the same factors. So the nice part is when we do this, we really only need to do it once because we have the same answer here. So I have x plus 6. Now, if you want to write it out twice, that is okay. But just now, you'll get the same answer here. So I set my x plus 6 equal to 0. And notice I get the same answer of x equals negative 6. Okay? Okay, make sure you watch the last part, which is going to be over a word problem.